All right, students, so let's look at lesson 6 for classifying and evaluating computers. Now, computing has certainly changed. It used to be we had two choices. We could either go with a desktop or a laptop. And now there's a ton of choices for us. So let's go ahead and get started. So the objectives, we are going to look at the types of personal computers. We're going to look at desktops, laptops, tablets. We'll look at all-in-ones. We'll look at two-in-ones. What the heck is a two-in-one? Next thing you know, there'll be a 3-in-1. We have smartphones. We'll look at embedded computers and then just briefly look at servers and stuff like that. So here's the words you need to know. That all-in-one, that convertible, they call those now 2-in-1s. So you might hear that term. Desktop computer, eBook reader, electronic paper display, embedded computer. We'll take a look at all of these. So more words to know. What the heck is a personal computer? How does it compare to, say, a workstation, for example? And we'll go through that as well. So preparing to purchase a computer. So 3 categories: personal computers, embedded computers such as ATMs, and then large computers such as servers. Now, you've been introduced to servers from the server room, and basically, those are computers that run specific applications such as databases that a lot of personal computers or workstations can access. So a personal computer, they say, is a computing device that can perform input, processing, output, storage on its own. Well, guess what? My phone can do that today. So is my phone a personal computer? In a way, it kind of is, yeah. So we really need to look at usage, typically falls into the following ranges. So a basic user, someone who might surf the web, do some basic email, word processing documents. Intermediate, so frequent use of variety of tasks. So play games, watching videos, shopping online, using productivity software. This might be the person that has multiple applications or programs open at the same time. They've got a browser open, they've got Word and Excel, and they're working away. And then, of course, advanced, performing tasks that require maximum amounts of availability of processing speed, memory usage, storage capacity. So most people are going to think about gamers when we talk about this, because PC gamers want the most power that they can get, the most memory, store the whole game in memory, process quick, big screens, etc. But this could also be someone who does, say, graphic design, for example, or utilizes their personal computer or workstation to, say, produce videos. And we'll take a look at a little bit of this so that we understand what size computer we need. So you definitely want to be careful with buying a computer. First of all, does it meet our need today? Okay. And what is it we plan to do with it in the life of the computer? So, most people replace their computer every 4 years. So the quality of a computer is determined by a lot of things. Yeah, so here's a great example. Processing capacity. Is it 32-bit or 64-bit? Well, today, 64-bit is really where it is. That's pretty much the default now. But as we've seen, processors, there's a ton of different processors out there. There's Intel and AMD. Those are the two main competitors. But there's dual core and quad core and hex core and 12 core processors, and we'll take a look at some of those as we go through this presentation. Memory is a big thing. We want to make sure that initially in the onset of purchasing a computer, do we get ample memory for our needs? So we'll take a look at a basic computer and how much memory we might need. Memory speed, is it DDR3, DDR4? Of course, if it's older technology, not the greatest or leading edge or bleeding edge technology, we're going to get a price break on that. So do we necessarily need to buy the latest 6th generation Intel i7 quad-core processor with DDR4 memory and all that good stuff? This will all make more sense to you here in a little bit. Storage capacity. Today we talk about terabytes of storage. We store a lot of data, even on our personal computers. In my phone, I have a 64 gigabyte micro SD card, for storing pictures. It takes 12 megapixel pictures on my phone, plus all the applications and the data for those applications that I use. It's a lot of stuff going on today. We need a lot of storage. and then storage speed. And as we know, we're looking at two different things today. We're looking at that traditional magnetic hard drive versus solid state. And of course, because solid state is newer, it's going to be more expensive. All right, so let's continue on. Desktop computers, this should look pretty familiar to you. We have desktops, and now, since Mac came out with the all-in-one, where the entire tower, the CPU, the memory, the motherboard is actually inset behind the monitor, so that we get rid of this component. We get a basic keyboard, mouse, and off we go. So the system unit here is the tower. That's where we're going to find the motherboard, the video card, the processor, the memory, any expansion slots that we've put in there for different functions. Here's that great example I was talking about, the all-in-one. So, Mac did it first. Here it is. Streamlined, very thin, easy to use, large, high definition screen. Are we going to pay more for this? Yes, because we're putting smaller components in here and we're getting rid of that tower. Now, most of you today are using laptops. Laptop sales exceed desktop sales now. Amazing. But really, what's a laptop today? Well, a laptop is that traditional, I have a screen, I have a keyboard, it's all in one unit. Some people call them notebooks. We've seen the Macs, the Mac Air, how thin they are. It's just amazing the technology we have today. So netbook computers or ultrabooks look like laptops but are smaller and lighter, tend to be less expensive. I would probably say, and don't hold me to this, but the Google netbooks that are out there today, running the Google operating system, that's really a netbook. They have very small processors, they have very small storage, because the intention is most of the work you're doing on those computers, you're doing in the cloud. You're using Google Docs, saving your files out there. That brings us to tablet computers. Now, be careful when we talk about, digital readers compared to tablet computers, because a digital reader is designed just for that, for reading books, where today our tablets are computers. They can get us out to the web. We can process. My tablet has Microsoft Office on it, so I can really be almost fully productive with that tablet and a nice little keyboard, but granted, it's not going to have the processing power or the memory. And then there's convertible tablets or two-in-ones, and we'll take a look at all these so we can get an idea of the differences here. So as we compare all these things, we're looking at processor power, we're looking at memory, we're looking at storage, we're looking at size. We're looking at battery power, and we're deciding what we need. For my needs, I stay away from the little 13-inch screens. They're small. They're difficult for me to do video processing or have multiple screens open. So I use a 15-inch so that I can be productive just on the laptop. And then, of course, I connect it to, at home, a 40-inch smart TV so that I have a big screen in front of me. So, tablets and laptops, well, on the laptop, we get a nice traditional keyboard, tends to be faster for most of us to enter information in. On the tablets, we get either an on-screen keyboard, or now, because tablets have become more popular, we can get a little Bluetooth full keyboard that will work with these as well. So battery life, we need to look at storage capacity. At any time, go ahead and pause this if you want to read this in more detail. So remember battery life. They really like to sell on battery life. So when you see a computer that says, hey, you can get 10 hours of battery life, it's probably at the point that they're using it independently. They've done some power saving, so they're not using the full processor or the full memory or the full functionality of, say, the laptop or the tablet. And so keep in mind that battery life, especially if we turn on the Wi-Fi radio, if it's got an optical drive in it, it's going to be lower than they suggest. Performance, definitely a deal. So remember, as we make these units smaller, as we make computers smaller, we put in smaller processors, we put in less memory, so the components themselves you're not going to get the speed from my laptop, which is an i7 quad core with 16 gigs of RAM on a 512 gigs solid state drive. You're not going to get that from a little 8-inch tablet, for example. Physical factors. So, where is it you're going to use your computing device? How are you going to use it? That's going to really determine what you do. Most of us today tend to have a tablet. We tend to read on it, maybe surf the web, do the Facebooking thing. Highly convenient, sit in front of the TV. My tablet at home is a Samsung. It'll change my TV if I want it to. But I also have a laptop computer with much more power for all the things I need to do. Price is huge. We'll go take a look at price. And then, of course, the usage. Today with smartphones, a new smartphone coming out, every year, for example. Verizon, I think, has a deal. You can sign up, pay a little extra, and every year you can get the latest iPhone so that you have the latest and greatest. But smartphones, touch screen, multi-core processors, RAM, and then, of course, we can add additional storage as well. So amazing what we can do on these. GPS, email, messages. Could I be productive for a while on my phone? Absolutely. But am I going to edit a video on it? No, I'm not. Actually, I just set up my phone with a VPN connection and a remote desktop so I can actually manage the servers in the computer lab from my smartphone. So amazing what technology and improvements in the internet has allowed us to do. So when you're looking at smartphones, two main brands. You've got the Apple iPhone, and then the Samsung Android. Android operating system is definitely taking over the majority of market share. More people are writing apps to them. Open source sort of, because most of the carriers then are taking that open source application and making it more proprietary, adding specific features for their carrier services. So, smartphones, battery life, again, storage capacity. How much are we going to store? If you're one of those people that wants to take their smartphone on vacation, you're going to need a bunch of storage for pictures if you take pictures with it. And if not, then you don't need the storage. Multi-core processors, more RAM. We're improving the quality of the smartphone. You can even use one of those Bluetooth keyboards on your smartphone. So amazing technology today. Price, we'll take a look at that. Computer usage. Again, if you use a computer only to access the internet and communicate with others, a smartphone might be the only computer you ever need, even to do your email. But what if you're using it for more? And we'll take a look at that. So let's quickly jump out and we'll take a look at some of these things we're talking about. So let's go out to, first of all, knowing the system requirements is huge. So I've got 3 things up here. We're going to look at Windows 10. And according to the Microsoft website, notice I'm on Microsoft here, it says I only need 1 GB of RAM for the 32-bit or 2 gigs of RAM for the 64-bit operating system. I need 20 gigs of space on a 64-bit. I need a DirectX or later driver for the graphics card. And then the display of 800 by 600. Now I find this funny, 800 by 600. Today 1920 by 1080 is a pretty big standard. So as we look to build the computer, a couple things we need to look at. Number 1 is stacking the RAM. So if we're going to run an operating system, we need 2 gigs for that. Then let's go out to system requirements. So I'm on the Microsoft Office suite. So this is our Word, Excel, PowerPoint, Outlook, etc. And if you notice here, for Office Professional, which is the big version, we also need 2 gigs of RAM. We need a certain processor here, 3 gigs of available disk space. So it's not really going to take up a bunch of space here. Display, here we jump up 1280 by 800 screen resolution. Why would the Windows 10 support such a small screen? Well, maybe we want to use it on, say, a smartphone or an embedded computer that's in our car or something like that. So, operating system. So as we purchase Office 2016, notice it's going to run all the way back to Windows 7. So they're guaranteeing it'll work on Windows 7. You XP users, you may be out of luck. But notice here with memory, so we had 2 gigs here for the operating system. Now we're needing 2 gigs of memory for Office. We're up to 4 gigs that we need on a computer. Now, if this is all you're going to do, maybe 4 gigs will work. I suggest adding more RAM. You just never know, and you don't want to buy it for a laptop after the fact. It tends to be more expensive. Plus, in a laptop, we only have 2 slots for RAM. So if we buy a laptop that has 2 slots, each filled with 2 gigabytes of memory, and we want to replace them, we're going to take that 4 gig and throw it out and put 2 new sticks in there with maybe 4 gigs each. So keep that in mind. Make sure you get enough RAM when you purchase a computer. Now, we were talking about advanced users. Here's a program, Sony Vegas. So we use this to do video editing. Movies, full feature-length movies are edited in Sony Vegas, for example. But let's look here at the requirements here. So Windows 7, a gigabyte of drive space just for the application. But notice here, if we're going to do 4K media, we need solid state or high speed multiple disk RAID. So we need to be able to read and write to those disks really quickly. And notice here, 4 gigs of RAM suggested, 8 gigs recommended, and 16 gigs for 4K. So what that means is that we want to put as much of the video that we're processing, editing into memory. So if we're going to run this program, okay, we have 16 plus the 4. We're looking at about 20 gigs of RAM if we're going to do 4K media. The biggest thing tends to be things like sound cards and what kind of video cards are supported. So we have to make sure that our system supports all of these if we're going to run Sony Vegas efficiently. So as you can see, you get all the programs you're running, you stack them up. Now, am I going to run Office and Windows and Sony Vegas at the same time? Maybe not. Maybe I know I'm going to run the operating system, so I need 2 gigs there. And then I know I'm going to do 4K media, so I need 16, so I'm at 18 gigs of memory in a computer that I need. What computer would run this well? Well, it just so happens I'm going to go over to Costco here and give you an example of a high-end computer. This one happens to be on sale right now, so let's take a look at it. It's a Dell XPS 8900 desktop, okay? And let's look at its specifications here. So it's got an NVIDIA GeForce GTX 960 graphic card, so we'd want to make sure if we're running Sony Vegas that Sony Vegas is going to run on this graphic card. 2 terabytes. It's got an i7 processor. It has 32 gigs of RAM. And if you notice here, the hard drive, it's got a hard drive with 2 terabytes, and it has a solid state drive with 256 gig. So we could load our operating system and Sony Vegas and Office and all those great programs onto our solid state so we know it runs fast, and then store all the files and movies we create out here. So there's a great example. Let's quickly look at all the different types of computers that we were talking about briefly in this presentation. So laptops and 2-in-1s. So for home, let's go out and look at laptops and 2-in-1s. Here is a typical laptop. These are 2-in-1s. So what this gives us is it gives us a tablet PC, in a thin architecture. So we can use it as a tablet. We can flip it over. Behind here is a keyboard. So these are, fun, and it comes in, 15-inch. So I can look at a 15-inch 2-in-1, okay, and there it is. So if you notice, very thin, this would be great for me to have. That way I could use a digital pen right on the screen as I do this presentation. So, wonderful computers to look at. Let's go back to products, and we'll go to desktops, and we'll look at desktops and all-in-ones, and let's do that for home as well. So we're not looking at workstations. Let's just talk briefly the difference between a PC and a workstation. When we talk workstations, like in the computer labs here at COCC, what you're going to find is the same computer on every single desk, so that when we manage these, we're managing one model or in the case of the college, I think they have a 4 or 5 year cycle. That means for the most part, they're going to manage 4 or 5 models only. So we're not going to have an all-in-one and a two-in-one and an XYZ and a PDQ all over campus. So here's the XPS all-in-one. Notice the tower is gone, and then we have the others, and then we have the high-performance gaming models, which are the Alienware. There's that Chrome box we talked about, or Chromebooks in a laptop format. So let's go back. Products. So we talked about desktops, we talked about laptops, tablets. So tablets for home, and then gaming. So Alienware desktops. This is a high-end computer. Okay. So as you can see, like the Area 51, 6 and 8 core processors here. Okay. Windows 10, high-end. Build yours. Notice 1600. Well, I guarantee I could put multiple video cards, bunch more memory, and get this price up to about $5 grand. And that brings us up to like the MacBooks. Let's go over and take a look at Mac. Here's MacBooks 15-inch, 2.2 gigahertz processor, i7, turbo boost to 3.4. So it's a 2.2 gig processor, 16 gigs of RAM, 256 flash-based storage. Think of it as solid state. $1,800 for that one. Add more storage here, and a little bit more processing power, it looks like. And we get up to $22.99. So there's that MacBook Pros, sort of the same information. Let me jump out to Mac here real quick. And the Mac Pro. So this is, their new sort of desktop computer. This is a really interesting computer, as you can see. Information about it. Again, we can get up to 12 cores in here. So let's go out to MacMall. I went out to MacMall and I found this Apple Mac Pro, 12 core Intel. We talked about this on the first homework. 64 gigs of RAM on this little computer in here, 1 terabyte, a terabyte of the flash-based storage, dual AMD Pro video card, and the Mac El Capitan, and we're looking at just a small price tag of on sale today at $8,800 for this computer. So amazing, $8,800. $1,400. So just make sure that you're shopping, you're being smart about making a purchase that's going to work for you and that you're not overbuying what you need. So mobile devices, portable music players. I'm not sure, I wonder how these things stay in business, portable music players, given that my phone has enough storage with 64 gigs. I use Google Play for my music. All my music is up on the web. I can download, cache it to my phone so that I'm not using bandwidth, and play my entire storage library if I wanted to. So other mobile devices, we talked briefly about eBook readers, electronic paper displays. So, definitely the Kindle. One of the nice things about the older Kindle is it had that electronic paper display. You could read it in the sunlight. My dad has an old Kindle that he takes to the beach. First of all, it's old, doesn't care if he loses it. Second of all, it's much easier to read than to, say, reading an ebook off of his tablet with the screen that doesn't work well in the sun. So mobile media players, handheld gaming devices. Then we get into things like embedded computers. So is a processor built into a household appliance or other device, ATM, dedicated navigation system? Yes, folks, refrigerators. So imagine this, a computer in your refrigerator. Eventually, milk's almost empty. You use the UPC code, you scan it in, that information goes to the store, they start creating a shopping list. You go to your refrigerator, seems like a great place to go. You click order, and your entire order is sitting there waiting or gets delivered to your house based on what you've ordered. So television, most televisions now are computers. They have that processor. The smart TVs now have wireless. So I can connect directly to the web. I can surf Facebook. I can get on Netflix. I have everything I need inside that television. So appeal and strength of an embedded computer. It adds computing power to a device without needing intervention from a user. So DVRs. So, the Ben Broadband DVR, for example. Backup camera. So I think it's by this year that all new vehicles coming out this year have to have a backup camera. You stick it in reverse. My new car has one. They are just awesome. It's definitely a safety feature, and definitely pretty cool to have. So you got backup cameras, you've got side view cameras coming in. All of that stuff requires a processor to process that video and information, definitely. So servers, we've talked enough about servers, I think, but servers tend to be these large-scale computers, multi-core processors. So the high-end processors, they can have 128 gigabytes of RAM. They can, have a petabyte of storage, or definitely easy to get a server with 10 terabytes of storage in it, for example. A lot more processing power because these are storing information. So a standard server that you might be aware of is an email server. So here on campus, Microsoft actually hosts our email. They have a huge server. It hosts all of our email and sends it back to email clients like Outlook or out to the web using that Outlook Web Access, or now Office 365 interface that you just simply go to a browser to get. So you've seen examples of servers and server racks. These servers may be performing the same function or different functions. It's estimated, I read an article a while ago, that when you go out to Facebook and do all the things you do at Facebook, you're hitting hundreds of servers at a time. There's the game servers, the servers that host pictures, the servers that host the database, the servers that host the games and the ads that you see and all that stuff. So that's why we need these huge data centers for all of that information that we're now posting and storing on the web. So servers usually are dedicated to a single type of task. Yep, a web server, for example, is going to host a website or now web-based applications. Easiest example used to be if you were an accountant, you bought QuickBooks and you installed it on your computer and you did all your financials from there. Now you buy QuickBooks online. And what that means is you can go to any computer and you can manage your QuickBooks, and QuickBooks, or Intuit, the company that does QuickBooks, stores all that data to the web. So what's the challenge with that? Definitely security. And security starts with your password. So if you've ever wondered what kind of silly things people use as passwords, just go out to Google and type in top 25 passwords of 2015. The list may shock you. So other things like file servers, we have one of those here. When you log into the campus and you go to My Documents, all those documents are not stored locally on that personal computer or workstation. They are stored back on a file server. So more on servers. They are highly scalable. They are redundant. So if a power supply goes down, they tend to have two. You never want a server to go down because it's serving so many people that if, say, COCC was to lose its email server, knock on wood, we wouldn't be very productive till that thing came back up. So all servers need reliable network adapters. Mainframes, the old mainframes, don't need to go much into those. We're in a room. We sat in another room over here with dumb terminals, and all the processing was done back on mainframes. Now, mainframes still exist today, for doing things like high process work, looking at compounds and how compounds might intermix with each other, how they might affect a disease, for example. So a lot of great things still being done. Large organizations rely on mainframes to process and store data. I'm pretty sure Banner, our main system here on campus, is still sitting on a mainframe computer. So I know Les Schwab uses an AS400. So archaic, still out of date, but a lot of mainframes still in work at companies. So supercomputers, and we tend to find these in the scientific or college areas, have processors with 1 million or more cores and are used primarily for scientific applications or complex calculations where we want to run through a ton of calculations very quickly. So that brings us up to the end. You can review the summary. I'll just briefly go through each thing. You can pause the video and read the summary here. And that gives you a great idea for Chapter 6 and your homework. Take care.